Hi there. In this video I'm going to go over inheritance, which is a technique that Java has for extending the functionality of a class by adding a subclass which adds some additional functionality without actually modifying the superclass or the base class or the parent class. All those are used, all those are terms for the class which is extended. So in this case, we're starting with the boat class, which has some basic functionality, and then that's the superclass, and then that class has two subclasses, kayak and powerboat, both of which add some additional functionality to the boat class. And then we have a third class, yacht, which is a subclass of the superclass powerboat, and it's also a subclass of boat. And it, in turn, adds some functionality to powerboat, but also has all the functionality of boat. So let's take a look at this quickly and see how it works. So here's the boat class, right? A very simple representation of some basic boat information. In this case, we're just storing the length and the width of a boat. Sort of the least information you could store about a boat. And we have a constructor in which we pass in length and width. And for the first time, I wanted to talk about the use of the this keyword. Up until now, I've told you that you should always use a different name for the constructor, for the parameter, parameters that are passed into a method than for the fields, right? Because otherwise, if you don't, Java gets confused. Well, that's one way to prevent using different names is one way to prevent Java from being confused. The this keyword is another way. What this means in Java is the object that this code is running in, right? So it means this object, and then you do this object's length field is one of the instance variables or fields of the method, as opposed to this local variable length, right? All parameters are local variables. So by using this dot length, we unconfuse Java. Java knows that, oh, you mean the field for this one, and since this doesn't have the this dot before it, you mean the parameter, right? So this is another way to avoid this issue of parameters being confused with fields, right? I like the this dot, both because there'll be other uses for this that we're going to get into soon. So it's a good habit for you to start using this with an understanding that this always refers. It gives the ability of an object to sort of say me, right? To point to itself and say, hey, me, my length field, and me, my width field, except it uses the word this instead of me, right? But it's the same idea. So oftentimes, as we move ahead, you'll see that it's useful to be able to have a reference from within an object to itself. And it also allows you to use, names that make sense and not having to add stuff to them or capitalize or whatever, just to make them different from the field names, right? So this. So the constructor sets these two fields of the boat. Then we have this method move, which simply prints out underway captain, right? Very basic boat. If we tell it to move, it says the message is printed at underway captain. Silly, but that's what it does, okay? And then we have a method, print boat info, that prints the length. Oops, and this should say width of the boat, okay? And let's go ahead and compile that. And we'll make a new boat object, and we'll say there's a length of 12 and a width of 2, and say okay. And here's our boat object, and now we can say move, and it's going to say underway captain, because that's what we told it to do. And we can say print boat info, and it prints the length and the width of the boat. Straightforward, right? Okay, so these arrows with the open triangles at the end indicate that these two classes extend the boat class. And let's look at Powerboat first. And you actually, when you're extending a class, actually write the name of the new class, and then you write the word extends, and then you say which class are you extending. So in this case, we're extending the boat class, because we want to add some new functionality that just applies to powerboats, but uses also the basic functionality of the boat class. So in this simple example, we're just going to say, for the powerboat, we also want to know the horsepower of the powerboat, right? So its constructor takes in three things: horsepower, length, and width. Right? Now, we use the keyword super to say basically, hey, superclass, I'm going to send in these two parameters for your constructor, and you're going to set those fields, right? So the super here calls this constructor, because this is the superclass, and it passes in length and width and sets those two fields appropriately for the object, any object of the powerboat class. Right? It's a little strange, but really pretty straightforward. Right? Since we've already got code that does that, we'll just use that code by saying super, which tells Java, hey, call the superclass's constructor. By the way, this line in the constructor always has to be the first line. You can't put it the second any other place. It has to be the first line, right? And then we just say this horsepower. This horsepower field is equal to the horsepower parameter that was passed in. All right. Now, we already have in the boat class something that says underway, Captain. But with a motorboat or a powerboat, we want to start the engine first. So we've got, for the move method of powerboat, which has exactly the same name as the move method of boat, so this is known as an overloaded method, the move method here will first output system.out.println starting engine. And because we don't have to do this, but because we want to also say underway, Captain, we write super.move, which calls the move method of the superclass, which is, right, underway, Captain, because boat is the superclass. Right? And then under we have a print boat info, which also exists in the superclass boat. This overloads it. So what this does is it, in this case, we call the superclass print boat info first. Unlike with the constructor, where the super call has to be first, any other place in any other method, the super call can be anywhere within the method. So here we're calling super.printBoatInfo, and then we're adding an additional print statement that will print out the horsepower of this particular boat. So let's see this in action. So we'll compile this. We'll make a new powerboat. We have to supply three things here. The horsepower, say it's a 40 horsepower. We'll say it's 18 feet in length and 5 feet wide. Okay, so let's see what happens when we do move. That says starting engine. That came from this class, the subclass, and then underway captain came from this class, because this class, remember, is extending this class. It sort of contains everything this class has, plus whatever new stuff we add or whatever we change. All right. Now we'll call print boat info. In this case, instead of just width and length, we also get horsepower, 40. Cool. All right? So let's take this one step further. A yacht is a powerboat, but it has some additional functionality. We could argue about what that is. I'm saying, well, I'll show you. I'm saying the additional functionality a yacht has is that it has cabins. All right? This is not important. This is an accurate description of the difference between a yacht and a powerboat, just for illustration purposes only. So yacht extends powerboat, right? And we already know that powerboat extends boat. So the one additional piece of functionality that yacht has is it keeps track of the number of cabins for powerboats. So its constructor takes in cabins, horsepower, length, and width. It calls the superconstructor for its subclass, which is powerboat, and that constructor requires a horsepower, length, and width. And then we set this dot cabins equal to cabins that was passed in, right? The move method outputs venting engine room, because in big boats, before you start the engine, you want to vent the engine room so you don't have an explosion. And then it calls super move, which is the move method of the powerboat class. And then we have a print info, which is going to call super print boat info, which will print out everything but the cabins, and then we'll print out the cabins here. So let's look at what this does. Compile that. New. So they'll say we have 5 cabins. Say it's a big 550 horsepower engine. Its length is 40 feet and its width is 20. It's a big boat. Okay. Now, by the way, if we inspect this, we'll see that although the only thing that we actually declared, the only field that we declared in yacht was cabins, through inheritance, it has these other fields of horsepower, length, and width. Okay? Important concept. So let's see, we're going to move. So this says venting engine room, which comes from the yacht class, starting engine, which comes from the powerboat class, and underway captain, which goes all the way back to the boat class. Right? And print boat info, so this prints the length and the width. Those print statements are actually in the boat class. Prints the horsepower. That print statement is actually in the powerboat class. And then finally the cabins is printed from a print statement in the yacht class. All right? So now we'll look at kayak, which is also a subclass of boat, another type of boat. Kayak extends boat. So an important number for kayaks is how much they weigh. The lighter, the better for paddlers. So we're going to store, in addition to the boat information that's in boat, the length and the width, we're also going to store the weight for any kayak that we have. And here's our constructor. Same idea. We call the superconstructor of boat, passes in length and weight. We say this dot weight equals the weight we've passed in. And for our move class, we say started paddling, and then call super.move, which at this point I hope you get, is going to say underway captain, because that's what the move method of the superclass does. And here we're going to print the boat information. Super.boatinfo will print length and width, and then we'll add the weight here. So compile, new kayak. We'll say weight is 20 pounds, length is 12 feet, width is 2 feet. So there's our kayak object. If I do move, it says started paddling. That came from the kayak class, and underway captain came from the boat class. And if I do print boat info, prints the length, the width, which come from the boat class, and the weight, which comes from the kayak class. Okay? So basically again, this is reiterating, what inheritance allows you to do is make use of existing functionality in a new class that builds upon that functionality and adds the subclass, adds additional capabilities, but doesn't have to reproduce the capabilities that are in the superclass or the parent class. All right, let's look at one more class here called boating. So in boating, we declare an array of boat objects called fleet. Then in the constructor, we actually make the new array, boat, and has 4 positions, 0 through 3. And then we say fleet sub 0 equals new boat, makes a standard boat. Fleet sub 1 equals a new power boat. Right? Now this at this point you should be going, that's interesting. I thought this was an array of boat objects. Well, through inheritance, you can store subclasses of objects in an array declared to be of the parent class. So this is boat is of the parent class, so we can store any objects of subclasses of the parent class within that array. So we can make a new powerboat, we can make a new yacht, we can make a new kayak. Those are all stored in this array of boat objects because they all are boat objects. They're just boat objects with different characteristics. Okay, now here's where you start to see some of the power that inheritance can give you. We don't have to worry about printing out about which type of boat we're telling to move. We're sending the move method because Java will keep track of that and it will call the appropriate move method for the appropriate boat object. So it knows whether the boats at position are powerboats, boats, yachts, or kayaks. All right. So what we're going to do here is a loop that goes from 0 to fleet.length 3, actually 4, because we're less than here, and we're going to call the move method on each of those boats, and then just print out a line. So let's see what happens when we run that. New boating. And go boating. And it first writes underway captain because the first object, let's put that over there, and I need to get that up. Okay. Because the first object is just a straight boat at fleet sub 0, and boat's move method just does underway captain. The second object is a powerboat, so its move method says starting engine and then calls the super method, which writes move method, which writes underway captain. The third object is a yacht. Its move method writes venting engine room, then calls its super method, which writes starting engine. That method in turn calls its super method, which is in boat, which writes underway captain, right? And the third object is a kayak, and its move method says started paddling, and its super method, super classes method says underway captain. Okay? So I understand that this takes a while to wrap your head around. And I think the best way for you to sort of get that process started is for you to create your own inheritance hierarchy like this with 5 classes, but on some subject different from boats. You can do whatever you want right? You could do animals, you could do cars, you could do anything that has evolved from or developed from one type of from a simpler to a more complex state, right? And there are a lot of things like that. So I will send this to you to use as a template, but you should come up with your own they could be methods that are very similar, but should reflect whatever it is that your classes are representing in the real world. Okay? So I hope this helped. I may need to go over some stuff again in a future video. But again, the concept is you have classes with some functionality, and then you extend those classes by making new classes which extend the base class and add new functionality. And objects that you create of the subclasses have all the functionality of the base class plus whatever functionality is in the subclass, right? And including whatever fields are in the superclass are in objects of the subclass, even though they're not explicitly declared within that subclass. Okay? Hope this helps. If you have questions, please ask them. The questions will help clarify things, and ask them in the haiku discussion for Chapter 8. Thank you.